This video, we're going to take our second step towards graphing trig equations. And we need to look at what those equations look like. So a basic equation for either sine or cosine, y is equal to a sine, or it could be cosine, it'll look the same, of b x minus h plus k. Again, all of this will stay the same. The only thing that will change is either the sine or the cosine. So what all these letters mean, okay? So the A, kind of nicely, stands for amplitude. Amplitude is thought of as a vertical stretch. Okay, so for example, if I want to do, scooch this up just a bit so we can still see the thing. If I want y to equal 2 times the sine of x, you remember how before the parent graph, and this is just a very rough sketch, does this. If I change that amplitude now to a 2, that means its high and its low change. So that's what that amplitude, that 2, now takes it from its high of 1 to a high of 2. So remember, 2 places up from the midline. The next piece is on the back end. So back here, what we're looking at is this is a midline change. Okay, it's going to shift the whole graph up or down, depending on if it's positive or negative. Okay, so what might this look like? If I took y equals the sine of x plus 2, we know that, again, the normal parent graph of this only reaches a high and a low of 1. It's still going to keep the same amplitude, but now this part is going to move up by 2, this piece is going to move up by 2, and that piece is going to move up by 2. So what we did here, and that piece has to move up by 2, we just moved the entire graph up 2 places. If this was, say, a minus 3, then the whole graph would go down 3 places. And I always use those critical points. I use those maximum, minimums, and intercepts to help me know when and where to move things. Okay, next thing we got going on in here, and I'm going to rewrite so that we can see as I move my paper up. I'm going to write that equation again. So we've got y equals a sine b x minus h plus k. What are we going to do with those other pieces? Okay, so the h piece in here, this is going to give me a horizontal shift. This is stuff you studied when you did geometry transformations. So if we have a minus sign in there, a minus h is actually going to move the graph to the right. A positive h is going to move it to the left. So that means I may take my graph and it may move backwards by pi over 2 or something like that. We're not going to do a lot with horizontal shift, but I wanted you to know what it meant. Okay, and finally the b. The b takes care of, it affects period. So this is where amplitude's a vertical stretch This is my horizontal stretch. All right, so for example, if, make sure I got plenty of room there, if y is equal to the sine of 2x, I want to think about what I've got there. If b is greater than 1, then the period is less than 2 pi. So this tells me, the 2, that I'm going to do 2 cycles in 2 pi. So again, if I set this up, and this is 2 pi, and this is pi, we know again that our parent function starts here, and again I'm putting in those critical points, does this. Well, now I said that I want, because of the 2, I need 2 of these to happen within 2 pi. So what I'm going to do is I'm going to think about covering up part of this. And I'm going to cover that up for a second. And I'm going to put 2 more pieces in here, because now the whole thing has to repeat from here to here. So critical point here, 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 and here. So there's 1. And then I want to cover up and do it on the other side. Again, I'm at a high, back to the axis, at a low and back, and then I can sketch that in. So the green shows 1, 2, a frequency of 2 within 2 pi. Okay? Just so that you have an example of it, because I've been talking only about sine, let's also make sure that we can look at cosine. So if I want y equals cosine of 1/2 x, because this number here is between 0 and 1, that means we're going to make this thing stretch out longer. So again, if I draw my basic cosine graph, and we know again cosine starts at +1, bottoms out at pi, and comes back. There's 1 cycle. But this says from here to here, I only want that much. So I need to stretch this thing out and think about, okay, if only this much has to go from here to here, this is going to come over to here. This is going to move to here. And so now I stretch that, and that takes care of that half. Well, we know what's going to happen then is we talked about vocabulary last time, and we talked about frequency and things like that. So for this one, its period would be 4 pi. To do the whole green one, we'd have to go to 4 pi. Its frequency, we want to know how many periods in 2 pi. Well, from here to here, we only got that frequency of 1/2.